Welcome to this explainer. Today, we're diving into exactly how to tackle one of the most common and honestly, one of the most brutal senior data engineer interview scenarios out there. If you're gearing up for a senior role, you already know that technical depth isn't just about writing clean code. It's about how you troubleshoot when everything inevitably hits the fan. So we're going to master a notorious interview question using a structured framework that'll absolutely set you apart from the pack.
Picture this. You're in the hot seat. The small talk is over, and the interviewer drops this bomb to test your chops. How would you debug a Spark job that hangs indefinitely? It's a terrifying scenario in the real world, and it's practically designed to be a pressure cooker question in an interview. Look, they don't just want you to list off random commands. They want to see your brain working in real time.
Here's the secret. You absolutely must establish your core philosophy right out of the gate. Start your answer by saying something like, if a Spark job hangs indefinitely, I would first identify exactly where it's stuck rather than randomly tweaking configurations. Boom. That instantly tells the interviewer you're a calm, collected, senior engineer who relies on systematic deduction, not just throwing spaghetti at the wall to see what sticks.
So, here is our game plan for this explainer. First, the real motive behind the question. Second, our first stop at the Spark UI. Third, checking the usual suspects like Skew and Shuffle. Fourth, digging deeper into logs. Fifth, looking outside the code. And finally, nailing that perfect summary. Let's get right into it.
Step 1. The real motive.
You see, the interviewer really wants to see how you think. Anyone can memorize configuration flags or API calls. What they are actually testing for is your ability to navigate chaos. You need to give them a structured narrative. Show them that you can take a totally ambiguous problem, like a job that's just sitting there frozen, and systematically narrow down the variables until the root cause has nowhere to hide.
Step 2, your first stop, the Spark UI.
You've got to make it clear that the Spark UI is literally your very first move. It's the scene of the crime. Explain that you'd immediately head straight to the Jobs, Stages, and Tasks tabs. You're trying to answer a few specific questions. Is the job progressing at all? Is one specific stage just totally stuck? And crucially, are the underlying tasks actively running, pending, or constantly failing and retrying? This proves you look at the telemetry before you ever start guessing.
And here's a classic example to throw in. Tell them if you see a metric where 199 out of 200 tasks are complete, and it's been sitting like that for 20 minutes, well, you instantly know a single partition is the culprit. Giving a concrete example like this proves you have real-world battle scars. You know exactly what a stuck job actually looks like on the dashboard.
Which brings us to step 3, the usual suspects, Skew and Shuffle.
Think about it like this. If one task has been grinding away, burning high CPU on a single executor for 30 minutes, while another task finishes in 2 seconds and its executor is just sitting idle, yeah, you've got severe data skew. One node is carrying a massive, disproportionate chunk of the data and dragging the entire pipeline down.
But you wouldn't just shrug and point out the skew. You'd rattle off the exact fixes. You'd tell them you could repartition the data to spread out the load. Use a technique like salting keys to break up those massive groupings. Force a broadcast join if one side is small enough. Or if you're on a modern version of Spark, just make sure Adaptive Query Execution, AQE, is enabled to handle that skew dynamically at runtime.
Now, if it isn't data skew, tell them it's probably a massive shuffle issue. You know the drill. Huge joins or crazy aggregations creating giant shuffle files that end up spilling to disk or blowing up memory. To fix this one, explain you check the shuffle read and write metrics, increase the number of partitions, optimize your join strategies, or again, lean heavily on broadcasting smaller tables to bypass the shuffle completely.
Moving to step 4, digging deeper.
Because sometimes, let's be real, the UI is just unhelpful. If it's not clear, you pivot straight to the forensics, the driver and executor logs. You tell the interviewer you're hunting for specific red flags, like out-of-memory errors or garbage collection pauses in the executor logs. You're looking for fetch failed exceptions, disk full errors, or network timeouts. Point out that sometimes executors are continuously crashing and restarting under the hood, making the whole application simply appear like it's hanging.
And hey, don't forget the actual code. You'd review the application for silent killers. I'm talking about accidental infinite loops, recursive logic, or my personal favorite, repeated actions triggered inside loops, like calling df.collect over and over again. Also, point out that incredibly expensive UDFs or Cartesian joins can silently trigger massive, repeated jobs that make the system look totally frozen.
Oh, and a total pro tip here, bring up garbage collection.
If you see high JVM GC time paired with extremely low CPU utilization, your executors are literally frozen, spending all their energy managing memory instead of processing data. You'd also mention analyzing the DAG, the directed acyclic graph, to look for blocked stages at shuffle boundaries. This completely isolates whether your bottleneck is computational, related to data movement, or just a sheer lack of resources.
All right, step 5. Looking outside. What if you've checked the code, you've checked the logs, and the Spark environment is totally fine? This is exactly where you show them you are a true senior engineer. You highlight the critical difference between a job that's hanging, as in actively spinning its wheels in execution, versus a job that is simply waiting. A waiting job might just be lacking CPU cores or pending executors from your cluster manager, whether you're using Yarn or Kubernetes. The code is fine, the cluster is just starved.
Plus, Spark doesn't exist in a vacuum, right? You've got to check the alibis of your external systems. Your job might just be politely waiting for a blocked BigQuery or Kafka query to return. You check if reading from S3 or GCS is unusually slow, if a JDBC connection is bottlenecked, or, happens to the best of us, an auth token simply expired and the system is just hanging on a silent retry loop. Sometimes it's really just plain old network latency.
Finally, step 6, nailing the perfect summary.
Before you tie it all up, give them your foolproof fallback plan for when things get really weird and nothing obvious shows up. Tell them you'd reproduce the issue on a much smaller data set. Inspect the execution plan with the explain command. Crank up those log levels for more verbosity, and literally isolate transformations one by one until you find the exact operation causing the hang. This proves you never just give up.
Then, you hit them with a rock-solid, comprehensive summary. Say something like, my debugging approach is to first determine if the bottleneck is due to the execution plan, data characteristics, cluster resources, or external systems. I use the Spark UI to find the stuck stage, then analyze task metrics, logs, shuffle behavior, and dependencies. Once I isolate the root cause, I apply targeted fixes. That brilliantly ties everything from the UI down to the root cause into one highly confident package.
So, as we wrap up this explainer, I want you to ask yourself a question. Does your current debugging process actually measure up to this senior-level framework? Think about how you troubleshoot on a daily basis. Adopting this detective mindset isn't just a hack to pass an interview. It's about becoming a vastly more effective engineer. Practice this structured narrative, lean heavily on systematic deduction, and you'll find you absolutely hold the key to acing that next big career move. Thanks for joining me on this deep dive.